today we want to talk together with my colleague Eric Shatne, our experience and our initial findings about working with the first CCS project that's going to be put in commercial operations. And I'll let Eric start with the introductions of the project, and later on I will take over and talk about how OPC UA fulfills that promise. So Eric, with that, hand it over to you. I hope you can see my slides.
I don't see it, but I see my own. So we are at the opening slide, and then I ask for the next one after that.
Okay, sure.
Yeah. Hello. So Northern Lights is a carbon capture and storage project, a real project, and the photo we see on this front slide, it is from Øygarden. That is a place a little bit north from Bergen, the old Hansa-Stadt. And we see here a jetty. That is, they are making a jetty out into the fjord there. And here it will be built, the world's first open CO2 source CCS value chain. So next one, please. Have you changed it, Kadri?
Yes, I have. Yeah.
Yeah. So that is, so this one show kind of this the global greenhouse gas emissions. That is the problem that we want to contribute to solving, and we see here that there is a big gap between the policies and actions and also 2030 targets. So, and the gap is of the order of 20 gigaton CO2 equivalents per year. So it's like 20,000 million ton. So it's a huge global gap here, and that gap needs to be closed, and CCS, carbon capture and storage, can be one part of that solution. Next one, please. Yeah. This one shows the European CO2 sources on the left-hand side, and EU has mapped about 2,000 sources, industrial sources in Europe, and we see that it's a contribution with different colors here, and the colors represent different kind of industries. So it's power and heat, it's non-metallic minerals, oil and gas, iron and steel, it's waste, it's pulp, it's many different kind of industries that contribute with quite big CO2 emissions. One part of the solution is then to capture the CO2 at the plant. To do that, you need to build actually a new plant, a capture plant, that is taking the fume gas and sorting out the CO2 from that through typically some amine process. Then you need to store it, and then you need to move it, transport it, and in the end you need to store it permanently. And we see here a ship on the right hand side. This is one of two ships that Northern Lights has in construction right now in a yard in China. Okay, so next one, please.
Yep.
Yeah, so the Northern Lights, it's supported very well by the Norwegian government, and the government take 8% of the costs roughly the first 10 years, at least for the first customer. And then it will start the operations in 2024. The first customer is Heidelberg Cement. And their plant is called Norcem, located in Brevik in Norway. It's located very close to the port there, Brevik port. So it's very easy to kind of store it at the port, and then you can pick it up at the port there. And you see on the photo or the illustration on the upper side, you see this huge structure in the this upper left corner, this structure is the preliminary well structure that will be put on the sea bottom in July. They will test and then this structure, inside this structure, the wellhead and the whole well will be located, and it will go vertically down 2.6 kilometers, and then it will be, the CO2 will be pumped into a saline aquifer at that depth. And this field or the storage site, it's located about 100 kilometers out from the coast, so you need a pipeline to transfer the CO2 from the coast, from this Øygarden. And the Øygarden you see at the bottom, it is preliminary storage. You have a tank farm there, and you have jetties, and you have ships coming in to deliver CO2. These ships, the first ships are 7,500 cubic meter cargo size, but we are looking at even bigger ships now. So in the first phase, we have 1.5 million ton. In the second phase, that we hope we can start later, it will be 5 to 6 million ton. Perhaps there will be one phase after that also. Next one, please.
Yep, done.
This shows the value chain, the whole kind of this business setup for this new industry of CO2 capture, transport, and storage. And to the left, top left, there are kind of new facilities, new customers coming into the value chain, and they will be linked up to this value chain. So the first customer here is this Norcem, as I mentioned. They are currently building a capture plant that you see in the middle between Norcem plant and this storage. Then you have this transport route from the industrial site to this plant and preliminary storage at Øygarden. And then they pump this CO2, liquid CO2, they pump it 100 kilometers out and into the well and down to the storage. Some of the first wells will be controlled from an offshore platform, and that is Oseberg A. It has DC power, fiber optics, and umbilicals for chemical injection and testing of valves and so on. And also there is going fiber optic cable from Oseberg to the shore, to Sture, not so far from Øygarden, and that there is a control room there where they will control the plant at Øygarden, at least in the beginning. Then we have, of course, offices, and we have authorities to deal with, to make all the reporting and get all these certificates for CO2 storage, etc., and get the permits to do what we want to do. Next one, please.
Yep. And
this shows this value chain and the future state vision. We kind of, when we talk about interoperability and asset administration shelf and OPC UA, etc., what we can do, what we want to do is to have this, to build actually this interoperability, that these different value chain elements can talk and they can work together without human intervention. So here is just an example. It's like exemplified, like a chat between value chain elements and not between people. So the capture plant might say, vessel 2, I'm at 70% of max CO2 capacity. Please see my 5 days forecast. When do you come and pick up CO2? Then the vessel answers, plant 5, I will slow down to save fuel. I'm ready to load in 3 days. Okay. Then these value chain elements can make deals and optimize their own operations. And then you have the port 1, for example, at Øygarden, they can report to the port where the ship was coming from. So port 1, here are your report for the CO2 offloading yesterday. So all this reporting can be done automatically. And also out in the sea, on the seabed, you have this huge template, and that can also communicate with the other elements. So guys, based on AI, I predict the optical fiber switch will fail in 3 months, suggest to replace while plant 4 has turnaround okay, and so on. So we hope that and our future vision is that we remove all the reporting, almost all human reports, and we do that automatically. Yes, and then please take over, Kadri.
Thank you so much. I mean, as you've seen, the actual physical infrastructure to do CCS is so complicated, and there's a huge amount of investments that's done, whether in terms of piping or drilling wells that are thousands of kilometers long. But a couple of things here. Why is CCS important? So one, CCS is the only way to decarbonize molecules. So industrial manufacturing contributes a big portion, probably the biggest portion of pollution. So it's the only way to extract the carbon from those industrial manufacturing plants. And then the second thing is CCS is also enabler in the network. So with things like blue hydrogen, which makes hydrogen, I mean, affordable, I would say, and abundant. With those kind of CCS enables hydrogen to play a bigger role in the energy storage industry. So that's why CCS is a key enabler. And to be able to run that complicated infrastructure, there's also an equally complicated digital infrastructure that needs to be built. Probably we can call it the digital backbone. And that digital backbone needs to be needs to communicate with a lot of entities. So as you've seen while Eric was explaining, there's the customer perspective. So the customers in this case, Norsum and Fortum, they have the capture plans, and then they have the storage units, etc. But they need to communicate with the Northern-Lights JV to exchange information, as you've seen in the last slide. So and there's similar things like I talked about Equinor running the well, and there's other things. So at this point, the 2 vessels are being run by Northern-Lights, but in the future there will be other ships, and also you need to integrate, you need to communicate with the authorities and with the ecosystem to run this. I mean, whether it's application providers or data providers. So to be able to run all of this kind of an infrastructure, you need an open and secure API that can scale and send these information, events, etc. And to me, that looks like the definition of OPC UA. And then the other perspective here is, again, there was a talk before today. All of these different components here, they're usually built and operated by different entities. So unless you build a standard model for all of these, and then to communicate between each other, it becomes a nightmare. So in that sense, OPC for data management and OPC UA modeling is a perfect fit for that. So that's why we picked that one, and now we're working on that to enable those. And in terms of like if you look into from a system perspective, like again, the value chain has a lot of things. So the typical CCS value chain usually starts with an industrial facility. The industrial facility could be world, by the way, for things like direct air capture. And then there's a capture facility, and then after the capture facility, you make that CO2 ready for transportation. It's transported. The transport could be in terms of pipelines. In Northern-Lights, it's through vessels. And then it goes to a central location. It's almost like the waste management transfer stations we have in the US, where the waste gets consolidated and processed, and it's been sent over to the end point where it will sit in the mother nature for the rest of the life. So I think, and to be able to do all of this, again, coming from a systems theory perspective, like today we have, for instance, OPC information models for things like pipelines, or we have like things like for pumps and compressors and tank farms. There's a lot of work that's been done already in those, so those could be usable. But I think the most important thing is for a system, it's much bigger than the sum of the content. So the real opportunity here is the arrows that you see in the middle. So those are these components working together to provide the CCS CCS capabilities, like metering or I mean safety interlocks, or in terms of like things like emissions reporting, etc. So there's a great opportunity here, and we would like to work with the OPC UA community, who has done this many times. One, to work on these subcomponents, things like capture facility, maybe the permanent storage, and also pull in the ones that we already have these OPC UA models, information models in place. But more importantly, look into the CCS value chain, and at some point maybe come up with a CCS companion spec that defines the information model from the systems data flows perspective. So we have a good idea of how this could be done, and we're working on it together with Microsoft and Northern Lights, and together with a big community. We're also reaching out to other industry standard bodies like OSTU and others, but we would highly welcome to collaboration here in that sense. Ben, as I mentioned, like this is from Equinor's the OPC UA information models. Aspen would absolutely know these, and this is the object types that was generated and open source. So there are certain things to start from. We don't have to start from scratch, and hopefully at some point put it in a companion spec for CCS. A little bit about our technology thinking. This is still work in progress. Just keep that in mind, because the whole reason is this is the first time that a CCS implementation of such scale and such commercial approach has been done. There's a few projects here and there, but this is the first one that will be an official CCS project that will be run by an entity and provided as a service. And we're seeing a whole lot of interest and customer demand in this. But if you look into the OPC domain, it's very straightforward. So we have the production assets. So there are some modeling and data perspective from the production assets. There's also an opportunity there. Then where it's very standard, I mean, like edge gateways and cloud gateways, etc. We can get this data in through using OPC UA. It's a no-brainer there. I think the more complicated part would be the using the cloud library or OPC UA modeling to build the digital twins from a CCS perspective, from a CCS system perspective, and then also maybe leverage some of the asset-specific models in that sense. And example I can give there is like, so if you look into the asset level, and then let's say in the capture plant, it might be like predictive maintenance of certain things, operations of the absorption columns or whatever. But if you look at it from a CCS perspective, then you might want to add things like metering, or you might want to add things like emissions. So how much emissions does this CCS capturing generate? Because it will be important for reporting to the regulatory bodies, and second, basically you have to, if you're generating more carbon than the carbon that you're sequestrating, then that's a bit of a problem. So there's a big opportunity there, and there's also some integration points, as you see from other things. My colleague Eric Meinstedt will have a conversation around the asset admin shell, but as the asset admin shell matures, then the big opportunity is to be able to expose those models, as I've shown in the first slide, around the APIs, and now like everybody can talk to each other with the asset admin shell. And there are also other concepts, interesting concepts. Like I've been reading a paper yesterday. It's around building simulation capabilities inside the asset admin shell, so that like now you can get these different assets connected to each other and have an end-to-end simulation of the whole value chain. So that was the first one, the simulation and planning work stream that I showed. That's also important in terms of planning. And again, like we can talk about these, but from a technology perspective, like we've been testing this quite a bit, and now you can get data from a OPC UA system. You can send it over to like in this example, it's a Kafka broker, and event hubs could serve as Kafka brokers, and then it can go to a backend time series database. So you can replace these logos here or these icons here with anything, but it's a well-proven implementation, and we've been testing it also for Northern Lights, and also there's been a mention about MQTT, and there's going to be some conversations around MQTT. So that's a very quick intro. If you have any questions, we'll be more than happy to answer those. But as I said, the most important thing is like the North Star could be a companion spec for CCS, probably partnering with other standard bodies to build that. And with that, I will hand back to Eric. He's going to show an interesting concept. And though for those who have been in the metaverse discussions for some time, like I'm a great fan of Decentraland, and just it's an interesting concept. I think it will pick up in the next few years. So Eric will show us how advanced like they've been with Northern Lights with those digital twin technologies using those metaverse concepts. So Eric, I'll just run the video and I will leave it for you.
Tell me when you started.
I started, yeah.
Yeah, all right. So this is part of some equinor technology. It's called Echo, and here they use Unreal Engine version 4 together with Meta Quest 2. That was earlier Oculus Quest 2. So it's some gaming technology here. Now we enter from the locker room. We go into the seabed, and here we see the early phase well structure, and we have an avatar there. It's Morten Heggenes. He was the director of Echo, this digital twin visualization hub in Equinor. And this is just a prototype pilot project for subsea that we try to build the same as we have built for topside facilities. Equinor has perhaps about 53 offshore facilities, and now we move into the subsea also. So here we see an ROV, and we want to use this kind of technology to do the training when we are actually, before we do the marine operations. It costs 1 million Norwegian kroner or 100,000 euro for each day when you are out on the sea, and then if something wrong and you have to redo it, etc. It can be very costly if you get 1 week with the trouble. So we want to do the training for marine operation, what we call the HACID and HACCP, hazardous identification and hazardous operations planning, and then people can sit with VR and do this online and actually go through the installation program online with the Googles and work together. So this is a multiplayer environment. It works with 5 to 10 different people. So hopefully we will have good use of this gaming technology in our marine operations outside Øygarden. Thank you.
Yeah. Thanks, Eric. And just, I mean, taking the risk of repeating myself again, I mean, working as as a group to come up with the underlying OPC UA modeling and the information model for the assets, and in future extending those to asset admin shell models will be critical here, because there's going to be a lot of these CCS implementations, and there's going to be as we presented, even more with Northern Lights, like we're already wrapping up phase 2 and phase 3, and others will come. There's a huge interest. So the faster we can standardize, we have a greater opportunity as the community to build products easily that integrates with the whole infrastructure. But thanks, and hope it was useful. And again, apologies for the glitches at the beginning.